Good day, ladies and gentlemen. Thank you for your time, and thank you once again for joining us for the session. Now, as Rian said, I've been in the industry now at Geotab for 10 years almost, and I've been in the industry now for 15 years in the telematics industry, building solutions. Started off as a technician in the field, so exactly know what is required in the field and how things work in the field. So my topic that I'll be speaking on today is building solutions for various types of applications using IVMS. So what is IVMS? IVMS is in-vehicle management system. It's an electronic device that is installed into the vehicle that captures all the data from the vehicle. So basically, it could be location, speed, RPM, harsh braking, harsh cornering, who's operating the equipment. So yeah, there are three aspects that we need to look at when building telematics solutions. We need to ask what, why, and how. So my team, when we get a request for a solution, we work on a project scope. So we sit down together, we ask ourselves the question, what, why, and how. So firstly, we need to identify what type of equipment. It is very important that we know as a technical department the type of equipment that we'll be installing to. Could be generators, lifting machines, roads and transport trucks, any type of equipment that has a power source, that requires a power source, we will be able to monitor that device. So it is important that we need to identify first what type of equipment that's to be monitored. Secondly, we need to understand why is it important for the client to monitor this equipment. It could be because of the safety. It could be because of a fleet issue where the guys are abusing the vehicles. It could be because of productivity, or it could be a compliance-related matter. So we look at Geotab's 5 pillars of fleet management: safety, fleet, production, compliance, and expandability. So expandability talks about SDK. It talks about our IOX villages that you guys have seen on the other side. So our core device alone is a solution on its own. So if you want to enhance, add more value, or monitor more products or on your fleet, you have to use the IOX expandability. All right. Thirdly, we need to ask ourselves, how will this equipment be monitored? That comes to basically your product, the core device, the Geotab device. I've used an example as Valor. Valor is a temperature monitoring system, and Geotab. So you have your core device, which is the Geotab, and then you have your IOX harness. So when we know what type of equipment is that we're going to install the Geotab device to, then we also now identified the reasons why the client want to monitor that. Then we come to the last part, is how will this equipment be monitored? Do we need an IOX auxiliary to monitor the seat belt? Do we need the IOX to monitor the cargo door in the back? Do we need to install a IOX Bluetooth? So that is our last step, is implementing the hardware side. All right. So let's take a look at 3 IVMS solutions that Geotab Africa has worked on. The first one is an IVMS that operates in a high magnetic field area. Secondly, an IVMS that monitors the rotation of a drum sensor. And thirdly, IVMS that monitors locomotives with high voltages. I am sure you guys have seen it that side in the village. The magnetic field Faraday cage is one of the solutions that took me the longest to work on. I think it took me like 6 months to get to an exact solution for this because of the complexity of EMF, electronic magnetic field area. All right? So let's have a look at that, right? So the first one, it is we identified the scope challenges, right? The first scope challenge was the NFC reader on our device did not function in the EMF area. Our Go device has NFC shielding already in it, so 100% our Go device works in the area. All right? The second one was the standard relay that you get off the shelf, or that Geotab uses, our standard relays. That also did not function because of the context. So when it goes into the magnetic field area, the context doesn't open or is jammed, it's closed on the relay. So that was one of the scope challenges. And then thirdly, an electronic system override key switch. So what I'm saying there is the client required an electronic key, not a normal standard key, electronic key that works on voltages. So one key will operate any machine. So we had to install 60 electronic system override keys. So that is a security added-on feature for the client in cases where something happened to the equipment, the machine, and the machine is inside one of the bays that the hot molten, the hot aluminium is stuck in, and our device doesn't operate. So that is basically just overriding our system so that the equipment can move out of that area safely. All right? So the solutions that we came up with, the final solution that I came up with is designing a 3mm mild steel NFC enclosure. So we've tried for 6 months researching how to build a Faraday cage. And there's so much on the internet when you come up with, even the new wallets, your wallet has a built-in Faraday cage. Do you guys know that? A special wallet that you buy now, because of the credit card that has got an NFC. So anyone can walk past you with their credit card machine, the swiping machine, and they can just swipe it here by your wallet, and the transaction goes through, and you see how there's like 1,000 Rand debited from my account. So there's special wallets now that you buy that's got a shielding inside the wallet as well. So we started off with foil. We covered our NFC reader in foil, and foil didn't work. We covered our device in aluminium. There's a specific client that we worked with is in Richards Bay, and they aluminium smelter South 32. And we designed an aluminium casing. That also didn't work. We designed a 1mm, 2mm enclosure. That also didn't work. Only when we got to 3mm, then only when we got in there, it took the vehicle in the EMF area and then swiped our tag. It worked. So 3mm upwards, the thicker the metal, mild steel metal, the better. There are also other shielding that you can get as well, but is more expensive. So the 3mm was the cheapest one that we can get. We had to install relays designed specifically for this environment. When we were there in the field, even the Ford Motor Company was also there because our client had Ford motor vehicles. So when the vehicle goes in there, the solenoid's also jammed. So the vehicle gets stuck. So that also was the client, they had to get a specific solenoid for this type of vehicles as well. So we imported electronic override keys, one key for every device. So as you can see on that side, that's the final prototype. That's a prototype that we came up with. And there's a short video clip. I'll play it and it explains how the NFC works. This is basically now inside the electronic area. So basically that creates a shield. So the electronic wave inside the site, the wave just basically goes over the shielding like that, so causing our device or allowing our NFC reader to work in that area. The second one, IVMS that monitors the drum rotation sensor on a cement drum truck, and it's also there on the stand in the IOX village. The scope challenges that we got here is we needed to monitor both direction of the truck, of the cement drum truck. So on the cement drum truck, there's a mixing and there's an offloading. So we needed to monitor both rotation. We also need to monitor the drum speed. So what speed is the drum doing at the moment? Is he going fast enough for the cement to mix? If he's not going at that constant speed of mixing, when he gets to the site, the cement might be hard. So it is important that we monitored the drum speed, and if he was not, then we will have to advise the client, and our system generally creates a report, an exception that notifies the client. Also, monitoring the PTO of these trucks. Now, when the trucks are moving, the PTO doesn't have to be on the truck. So if the guys are driving with the PTO on, the RPM is quite higher. It pushes the RPM up. So that only happens when the guy is stationary and he has to switch on the PTO, and then he can activate the offloading. So we had to monitor the PTO of that as well. The scope solutions, we imported a magnetic proximity sensor, which is specifically designed for rotation, speed, and orientation detection. The monitoring of the PTO was done via the FMS gateway. On Mercedes, Volvos, any truck, they got a fleet management solution system already installed in the truck where you get engine data from it. So that's where we get the FMS PTO switch. If it doesn't have, if it's an older model, pneumatic switches, we do have that as well, and we can install it to monitor the PTO as well. Right? The third one was IVMS that monitors locomotives with high voltages. We know that the railway, the voltages are quite high. Some might go up to about 1,000 volts locomotives, but these locomotives are diesel engine locomotives, and they only run on 72 to 75 volts. So the scope challenges we had there, our device didn't can only allow up to 30 volts. So we had to okay, the high voltage there, monitor the horn. We had to monitor the water temperature, oil pressure on this equipment as well. And all those, our auxiliary harness only works up to 30 volts as well. So that was a challenge for us. We had to create an IP67 enclosure that locks. So our solution there was we had to design and build voltage converters that you can get off the shelf. But these are our converter modules there that monitors the horn activation. Every time the guy activates the horn, we get a signal on the auxiliary, water temperature, oil pressure, and yeah. So those are the solutions that we came up with there. Yeah. All right, so to recap, when building solutions, we basically need to identify the three aspects for ourselves when building solutions. We need to ask ourselves, we identified what type of equipment is to be monitored. We need to understand why it is important for our client to monitor this equipment. And thirdly, we need to implement how we will monitor this equipment, example, the hardware and add-ons, etc., etc. Right? Thank you for allowing me the opportunity. Any questions at this time?
I would like to know what steps can be taken if we want to integrate with Geotab, and to take that a step further, if you'd want to integrate more than one type of hardware device. So let's say maybe a clocking system and a camera solution. How would you go about doing that?
We use the same process. The scope when we do the project scope. It is we understand the type of equipment that we understand why we need to understand why, and then also implement how. So our device can daisy chain up to about 5 IOXs at one time. So the possibilities are there for integration.
Sorry, is that a question, sir?
Ricardo, sorry.
Yeah.
Ricardo, what happens if you want to go beyond the 8? If you want 8 inputs, beyond 8 inputs, using your IX expanders?
Beyond the 18.
What is your maximum?
I think it's 8, right? Yeah. Yeah, 8 IOXs. So you can have two IOX auxiliaries, but if you reach the maximum, there's not much after that. So it all depends what applications you want to use. So is it necessary for you to use all 8? So yeah, but that's the maximum the IOX add-ons we can add on. So maybe in the near future, there might be possibilities for adding more with the new generation devices to come in.
About the number of devices.
Okay, thank you.
Sorry, the reason for that is also the 8 auxiliary is basically linked on the power consumption as well. So the 8 usually we only do for AUX auxiliaries, you basically with a monitor door or a seat center or something else like that. But once you start going Bluetooth, Garmin harness that actually drains, more power. You don't want to put too much stuff there, because then otherwise you'll have customers complaining my battery gets drained. And obviously by default, everything is drawing current that you're actually connecting to our device. So you don't want to actually step over that sort of boundary. Then you also don't want to go to the effect of adding another battery just to run the telematics device in the vehicle or whatever the case may be.
Is it not possible to put certain devices to sleep? Conserve power that way?
Yeah, some of them do. But it just depends on obviously the application, how you use it. You can think of a refrigerator truck that runs maybe long haul. I mean, these Garmin will always be on, and you always want to monitor the refrigeration at the back. So again, application, based on the application, we sort of can work out something there for it.
So the software has the capability built in already. So you can switch off your external IX devices within 10 minutes, immediately 1 hour or 2 hours. So it's there. You can define it as well. So if you go into device settings, you can switch it off immediately. That will prevent power drain as well.
Would that switch off all the IOX inputs?
All the IOXs, yeah. Garmin, RS323, IOX scan, everything, yeah, it switches it off. Only after the ignition is switched off. So when the ignition is on, those devices can communicate. So if your alternator is not running and your ignition is on, that drains current from your battery as well.
Is there any timing devices? Timing devices for the IOX, either switching off or switching on? In other words, when you turn your ignition on, it would cause everything to turn on, or could there be any delays in certain inputs as well?
Sorry, yeah. So, I mean, specifically for the Garmin, the security industry, because a guy obviously stops and he stays, parks something else there. So you would typically keep that device on for at least an hour. So at least if he gets a call, it basically will come up on the display. After that, we'll basically go to sleep there. So in certain cases, you can actually put a time limit on various IXs to obviously do it there. If you want to go really intricate, then we obviously would have to look at the firmware way of, let's say, for instance, a specific application you want to do. Let's say if you're exotic like a boat, you want to turn off something on the boat, whatever the case is there. You can then actually write firmware that actually will do the kind of applications you want to do in the front end there as well.
So the only time that you're asking about is when the ignition is on, the devices will remain on. Only when the ignition is off, Then the devices, you can set the timer, or how long did the IOX devices stay on. Does that answer the question?
Yeah.
Okay.
Do you see each of the 8 IOXs different time shutouts, or are they all the same time?
Different time. You can set, no, that's one time for all the IOXs. So if you go into the software, any IOX device that's connected to the device, it will shut down all that at the same time. You can't set them off at different times.
Yeah, so to alleviate it, you would have to make a firmware then specifically for that application.
Yeah. So it is possible to build a SDK for that as well. So, yeah. Any other questions from the side? All right. Thank you. Thank you all.
Thanks.